Well, this is our third video in a series on solving trig equations such as this one. As we go along, I'm going to be assuming that you have certain information either memorized or so close to the top of your brain that you could write it down within a minute and a half. This is one set of information. I usually say you should have at least the 3 yellow ones just straight memorized. And you should be able to write this chart on a sheet of scratch paper within a minute or so. And similarly here, the Pythagorean identity and its variations. You should have the 3 yellow identities definitely 100% memorized. And as far as the other variations, you should be able to jot this chart down on a sheet of scratch paper within about a minute and a half. So, looking at problem number 1, I'm noticing that we have cosine and we have sine in the same problem. That's no good. We really need all cosine or all sine. So I think now would be a good time to use my Pythagorean identities. Cosine squared is 1 minus sine squared. So that's a substitution I can make. So instead of cosine squared, what if we write 1 minus sine squared, and then that will equal 1 minus sine x. Now let's get 0 on one side and see what we have. Well, interestingly, if I subtract 1 from both sides, those completely cancel. So far I have negative sine squared x is equal to negative sine x. Now, you might be tempted to divide both sides by sine x or negative sine x. You are not allowed to divide by a trig function. Sine x will sometimes be 0, and you're not allowed to divide by 0. It destroys the universe. Instead, let us add sine x to both sides to get 0 on one side. So plus sine x. These are not like terms, so all I can do is write them side by side. So sine squared x plus sine x, okay, is equal to 0. Now, as I prepare to factor this, I don't like the fact that it's negative in the front, and that's easy for me to fix. So I choose to divide everything by negative 1. Now, did I have to do that? No, but this is the way I like to do it. So this is now going to become positive sine squared x minus sine x is equal to 0. Now, I see that I have a common factor of sine x. So I'm definitely going to pull out the GCF of sine x and think about what that leaves behind. So that will leave on the inside sine x minus 1. Okay, now that I have factored it, I can use the zero product property and set each of these factors equal to 0. So sine x will equal 0, or sine x minus 1 will equal 0. This is already solved. To solve this one, I would just add 1 to both sides, so that'll give me sine x is equal to 1. Now, both of these look like they can be solved using quadrantal angles. So what I mean is, looking at the unit circle, look at the angles that are multiples of pi over 2. And think about the ordered pairs here at these 4 points. All right, we have 1, 0, 0, 1, negative 1, 0, and 0, negative 1. Now, sine is the y value on the unit circle. So, for this function, we're looking for the y value to be 0. So I see a y value of 0 right here, and I see a y value of 0 right here. That's why we have 2 solutions to this equation. This is angle 0, and this is pi. So 0 or pi. So now let's start over and look for the solutions to the other little equation. Again, sine being the y value on the unit circle, now we're looking for the y value to be 1. So I see a y value of 1 right here and nowhere else. So this is the angle pi over 2. So that will be another solution. All right, because of this side. So we have 3 solutions to this particular equation. Okay, so that is it for problem number 10. Now looking at problem number 11. Again, I see 2 different types of trig functions, secant and tangent. I really need this all to be one kind of trig function. So I am going to use my Pythagorean identities to make this transformation. I see that secant squared theta is equal to 1 plus tangent squared. So I could make that substitution. Secant squared can be replaced with 1 plus tangent squared. So that's what I'm going to do right here. Okay, so here is secant squared. So I'm going to replace that with 1 plus tangent squared. Okay, now it has a 2 in front of it, so I'm going to put the 2 outside of parentheses. And then I have plus tangent squared x minus 3 is equal to 0. This calls for the distributive property, so now I have 2 plus 2 tangent squared x plus another tangent squared x minus 3 is equal to 0. Now these are like terms, 2 plus 1. So this will be 3 tangent squared x. And then I'm combining these like terms, 2 and negative 3. So of course that will make negative 1. So I have 3 tangent squared x minus 1 is equal to 0. Now adding 1 to both sides, now I have 3 tangent squared x is equal to 1. Now dividing both sides by 3, all right, because these will cancel out. That tells me that tangent squared x is equal to 1/3. Now I need to unsquare this, if you will, and in order to do that, I'm going to take the square root on both sides. Be careful, when you take the square root of both sides of an equation, the solution can be positive or negative. So don't forget your plus or minus, or else you will be missing half of the solutions. So as I write the next step, sometimes I lose a student or two. I am simply taking the square root of 1 and the square root of 3 separately. The square root of 1 is 1, just plain old ordinary 1. And then square root of 3, I can't do anything with it, so I'm going to have the square root of 3. Now, I'm thinking about the values that I have memorized. The tangent of what angle is 1 over radical 3? Okay, the tangent of pi over 6 is 1 over radical 3. Now that doesn't mean pi over 6 is the answer. That means it's the reference angle. So I have just discovered that I have a reference angle of pi over 6. Okay, so once I know the reference angle, I draw the diagram. Alright, because I will draw myself a diagram of pi over 6's. So this is what pi looks like. Now if I split that in half, now I have pi over 2. And if I split it some more, alright, I've got to split this up into 6 pieces, so I'll do 3 over here. And I will do 3 over here. Man, this one's tough. Drawing this negative angle on this electronic device is just the hardest thing in the world for me. Okay, so this is a diagram of pi over 6s. There are 4 angles that have a reference angle of pi over 6. All right, above and below the x-axis. So these are the 4 angles that have a reference angle of pi over 6. The tangent of any of these angles will be some type of 1 over radical 3. 2 will be positive, and 2 will be negative. Now, we want the ones that are positive or negative, plus or minus. So for that reason, I'm going to keep all 4 angles as solutions. So we will have 4 solutions. This first one is pi over 6 itself, but then this one is 5 pi over 6. This one is 7 pi over 6. And this one is 11 pi over 6. So these are the 4 solutions. All right, number 12 is pretty interesting. I have 3 different trig functions here: cosine, sine, and tangent. Somehow this needs to become one trig function. So I am going to use my identities and such. Okay, eventually I'm going to use my identities to help me simplify this expression down. But first, I'm just going to use the fact that tangent is sine over cosine. So my strategy will be to simplify the left side as much as I can. So I have cosine x plus sine x over 1, if you will. And then tangent is sine x over cosine x. All right, all this equals 2. So right now I have cosine x over 1, why not? Plus, now here I have sine squared. If I multiply this together, I'm going to have sine squared x over cosine x, and that is equal to 2. Now, if I want to put these together, which I do, I need like denominators. So why not multiply the numerator and denominator by cosine x? All right, that's legal. So now at that point, I have cosine squared x over cosine x plus sine squared x over cosine x is equal to 2. Now, if I add these 2 fractions together, now that I have like denominators, that's going to be cosine squared x plus sine squared x all over cosine x is equal to 2. Now, here's where my Pythagorean identity kicks in. Sine squared theta plus cosine squared theta is equal to 1. That's the same thing as cosine squared x plus sine squared x. That's equal to 1. So this all becomes 1 over cosine x is equal to 2. All right, great. So now I have it down to being just a single trig function. Now I'm going to do the reciprocal of both sides. So the cosine of x is going to equal 1/2. All right, just did the reciprocal of both sides. Now, what was I going to say? Yeah, so the cosine of what angle is equal to 1/2? Well, hopefully you have memorized that that angle is pi over 3. Okay, now that's not the only answer. That is the reference angle. So I've just discovered that the reference angle is pi over 3. And so with that in mind, I will draw myself a diagram of pi over 3s. All right, so that will look like this. There are 4 angles that have a reference angle of pi over 3. Here, 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 and here. Two of them will be positive, and two of them will be negative. Cosine is the x value, so these two will be positive, and these two will be negative. In this case, we want a positive cosine, so these two angles will be the answer. All right, so one of them, the first angle, is in fact pi over 3. But the other one is, let's see, 3, 4, 5 pi over 3. So these are the two solutions.